Hello guys, happy Valentine's Day and welcome to Lim Gao Takes YouTube channel. Today I was too busy with 6-hour lectures and plenty of events, so let's put SPM at Math aside and have some chill topics. But before we start, I would like to remind you all that there is a surprise at the end of the video, so keep watching it until the end. Alright, let's start with today's topic. Revision on today's classes. Have you ever wondered what a year 2 electrical and electronics E&E student learn in a day? So here is everything that I learned today. Altogether 3 pages and 2 parts. Let's start. So here is the first part, the Ampere's circular law. We're given a toroidal coil here, and there's a current input into it and magnetic field created by the current. So Ampere's circular law states the relationship between the current and the magnetic flux created by it, and this relationship is given by this equation, and after some derivations you get this importance calculations where you can calculate all the parameters if given one another, and R1 is given by the larger circle radius, as you can see here. This is R1, and R2 is the smaller radius circle, and R here is the radius of this path. Okay, and RT is the radius of a red circle, which is a radius of the flux path. As you can see here, this red one is a flux path. And A is a cross-sectional area, which is this one, the cross-sectional area of a toroidal coil. And R is a radius of a cross-sectional area. B is a magnetic flux density, and phi is a magnetic flux, and its SI unit is Weber. Permeability is given by mu, and it is a multiplication of relative permeability of free space and the permeability of a certain medium. Okay, and H is a magnetic field density. Its SI unit is ampere per meter, and MMF, magneto-motive force, its SI unit is amperes times turns of a coil. So you can see all the importance formula here, and it's important to know how to plug and paste as an engineer. Okay, so I'm sure it's quite clear here, and this is all for electronics control classes today. Let's move on to math classes. So this is what I learned today: Gauss quadrature numerical integration. This is basically to approximate the area under curve of a given function. So if you are given limit of a to b and the function fx, integration of it, meaning this is the area under curve, right? So this is approximately equals to the sum of ci times f in the function of xi, where ci and xi are a sequence given by this is a set of ci and xi, and this whole thing is approximately the sum of multiplication of ci times f xi. So you can see this coefficient times with a function of x1 plus c2 times with a function of x2 plus c3 times with a function of x3, then plus until certain n. This n can be any numbers from 1 to infinity. Okay, and the thing we learned today is a special case where you put this x in the domain of -1 to 1, and fx can be a polynomial of xn, and this n can be 0, 1, 2, 3 to infinity, basically any natural numbers. Okay, so when you satisfy these two cases here, you will have the limit of this exactly equals to the sum of ci times with xi functions. So example is given by this table, where you can just sub this ci and xi into it and get the exact functions inside that. Okay, so when n equal to 1, meaning 1 point is chosen, 1 point meaning one set is chosen, like n is equal to 1, so there's only one set of c and x here. The c can only be 2 and the xi is 0. So you can say that the area under curve of negative 1 to 1 of fx is equals to c1 times with f x1, where the x1 is 0 and c1 is 2. So when the n is 2 here, your ci and xi have two sets, which is when c1 x1, c2 x2. So what to choose here? c1 c2 is all equals to 1, and your x1 x2 are plus minus 1 over square root 3. Okay, so you just sub in c1 f x1 plus c2 f x2. This is exactly equals to this whole thing. And when you want 3 sets of c and x, where n equal to 3, these are the things that you need to sub inside, where your c is 8 over 9 and 5 over 9. But since there are 3 sets, right, so there are 2 5 over 9 and 1 8 over 9. And when c is 8 over 9, your x is 0. When your c is 5 over 9, your x can be plus minus square root 3 over 5. Okay, so talking so much, you might be wonder, if you are given a function, limit, area under curve of limit a to b and fx, how do I change it to a limit of negative 1 and 1 in this form, where you can use the Gauss method? Okay, so here is the formula, where if you are given this a to b, the limits, and fx, the x, you can just sub in the a and b here. So you got the function of y, x in terms of y, and by differentiating this with respect to y, you get dx equals to 1 over 2 b minus a dy. This is easy, right? Since if you differentiate x with respect to y, this front thing becomes 0, and you only left this thing, and then you take out the y here. So you got 1 over 2 b minus a, and then you put the dy, push it to the right, you got this. And then you just sub these two equations into the equation given, where you can see this x is equal to this whole thing. I just sub it inside, and then this dx is equal to this whole thing. I just put it on this side. So you got the exact thing. You just refer to the table, you will get the value of exact value of fx if fx is a function of x to the power n. That's it. So here is the surprise. If you would like to see more videos about EdMath and engineering mathematics, or electronics module. Do subscribe, share and like. See you all next time.